Today we're going to go over a few examples of applications of linear equations. The first one we're going to look at, it said when 2 times a number is decreased by 3, the answer is 11. What is the number, right? So this one is the simple word problems. We just need to build it. So something like that, we wanted to know what we're looking for first. So looks like it's say what is the number. That number itself, we're going to use the variable x, unknown. So we're going to label what we're looking for first, and then go back to the problem using this variable x. I'm going to reconstruct this problem into the number sentence. So when it say when 2 times a number, time is going to be multiplication. So you're going to have 2 times number. When 2 times a number is decreased, so you're going to do subtraction. Decrease is the subtraction sign, right? Time is multiplications by 3. So you're going to subtract 3. The answer is 11, so you're going to put equals to 11. What is the number? Now we solve for that unknown x. So now we know that we're going to add both sides by 3 first. You have 2x equals 2, now 14 on the right side. And when you divide this by 2, your x is 7. What about if we're looking at example B? When 60% of a number is added to the number, the answer is 192. What is the number? So again, we're looking for number. We're going to use the variable x. And it said when 60% of number is added to the number. So how do we show, if number is x, how do we show 60% of the number? We're going to multiply this two. So it will be 0.6 times the number will be 60% of the number. So this is added, that will be additions to the number. Number, we know that we're going to use the variable x. This is going to be equals to 192. So if we rewrite this into the number sentence, we will have 0.06 is added to the number unknown x. This is equals to 192. What is that number? So we're going to solve that number. This one, we need to assume that we have 1 in front of this x. That's why your x is there, right? Then when you're adding this number with the variable, you get 1.6x. 1 plus 0.6, that gives you 1.6 equals to 192. And if you don't want it to deal with the decimal, then you can multiply both sides by 10. So then you get 16x equals to 1,920. And when you divide both sides by 16, you get 120. So that's the solutions you're looking for here. This is your x for that problem. So it's saying this is the number, and 60% of number is added to the number. That's going to give you 192, right? So you can check this. What's the 60% of 120, right? We can figure that out using the calculator, and which is going to be 72. So 60% of 120 is 72. So when you're adding 120 plus 72, you get 192. So it checks out that the number is going to be 120. Okay, example C. 70% of what number is 224? Something like this, I like to use the formulas. Is over of equal percent over 100. Where is going to be a part, and of is whole number, and the other side will be the same thing. 100 is the whole number, percent will be the parts, and usually this is all come from it. So there is the percent of what number is what, right? So your is given, of is something that you're looking for, and 70% is right there. So if we replace that, we will get is going to be 224, and let's do that with blue. So it will be 224 is of what number equals to 70% of 100, right? And once we replace to the number, we can use the cross multiplication. So it will be 70 times x and 224 times 100. In order to solve for x, we will divide both sides by 70, right? So your x is, let's say that's going to be 22,400 divided by 70, which is going to be 320. So 224 is 70% of 320. Okay, so if we look at one other word problem, it's a one number exceed another by 26. The sum of the number is 64. What are the numbers? So this time we are looking for number also, but we're looking for more than one number. So let's say we're going to have number A and number B. So we're looking for A and B. And let's go back to the problem and see if we can rewrite this word problem into the number problem using variable A and B. It's a one number exceed another by 26. So it means your second number is going to be 26 larger. So we will say if A is smaller and B is the larger number, then we could say A plus 26 is going to be the B number. Remember, the bigger number is bigger by 26. So that's why you're adding 26 to the smaller numbers to be equals to the bigger number, right? And then the next sentence said that the sum of the number is 64. So sum is adding. So A plus B, you're going to end up getting 64. And we're going to use those two to find one number first, and then we should be able to find the other one. So since I have here in the first equation, B is equals to this, I can replace this B by A plus 26 to make one equation with one variable. So then I will have A plus, instead of B, it will be 2 plus 26 equals to 64. So again, just replacing this to this B, right? Just replacing. And then we're going to solve for A. Oh, that's going to be A, right here. Let's make sure that's going to be A plus 26, right? And we're going to have 2A, so it will be 2A plus 26 is equals to 64. And when we subtract 26 from both sides of equations, we have 2A equal 38. And when we're dividing both sides by 2 to isolate A, we have 19. So look like our A is going to be 19. And if we replace that into here, we're going to get 19 plus 26 is going to be B, where your B is equals to 19 plus 26 is 45. So there's two numbers that we're looking for that problem. 19 and 45. Example 2, we wanted to solve formula for a variable. So if we're looking at A part right here, we have a formula given, P equals to 2L plus 2W. This is formula of finding a parameter for the rectangular shape, right? But they don't want you to solve for the formula, the parameter. They wanted to solve for L, and nothing else is given. So how do we do that? It means we wanted to move everything to other side and isolate only L one side. So the first thing I wanted to do is locating where my L is, right? So look like my L is right there. It means I'm going to leave that L and move everything else to other side. And we know that when we're moving or trying to isolate, we get rid of addition, subtraction first before multiplication, divisions. So look like you're going to subtract 2W first. So now you get rid of additions. It means you have P minus 2W on the other side. You have 2L. Now you wanted to isolate L by dividing by 2. Now you get rid of multiplication by dividing, which you get only L by itself, and the other side will be P minus 2W over 2. And that's all you need to do. Isolate the variable one side and move everything else to other side. Let's try another one. So this one, we have A equals to 1 over 2 times H times A plus B. And this time we're trying to solve for B. And let's see, where is a B in this formula? Right there, right? So we wanted to isolate that. It means we wanted to get rid of additions. This is the additions, right? Additions and all these multiplications also. And this one, because you have a parenthesis, you get rid of this multiplication first. So in order to get rid of 1/2, you're going to multiply by 2. In order to get rid of H that's multiplied, you're going to divide by H, right? So if I wanted to do one at a time, I'm going to first multiply this by 2 over 1, right? And do the same thing. Multiply by 2 over 1. It means I get 2A equal, and then 2 and 2 cancels out. No more fractions. I have H times A plus B. In order to get rid of H, I'm going to divide by H. Right? They cancel out. I have 2A over H on the left side, and I have A plus B remains. And because I wanted to leave the B by itself, now what I need to do is subtracting A. And subtract A on the other side, I get 2A over H minus A equal, that cancels out B. So your B is equals to this. And that's all they were asking you to do, not actually solving it, just rearrange your equations to be equals to one special variable.